We're now going to graph the polar equation r equals 1 plus 2 sine of theta. Once again, the first thing we want to do is check for symmetry. So let's check for symmetry with respect to the polar axis. To do this, we replace theta by negative theta. The result that we get is r equals 1 plus 2 times the sine of negative theta. You should recall that the sine function is an odd function. Therefore, the sine of negative theta equals negative sine of theta. And so this simplifies to 1 minus 2 sine of theta. Because this is not equivalent to the original expression, the graph may or may not be symmetric with respect to the polar axis. Now we'll check for symmetry with respect to the line theta equals pi over 2. Recall, to do this, you replace theta with pi minus theta. Now I have to evaluate the sine of pi minus theta. That is going to be 1 plus 2 times the sine of the first angle, which is pi, times the cosine of the second angle, minus the cosine of the first angle, times the sine of the second angle. Now do a little bit of simplifying. 1 plus 2. The sine of pi is 0. So I have 0 times the cosine of theta, which is 0. The cosine of pi is negative 1. So I have negative 1 is plus 1 times sine of theta gives me sine theta. So I have 1 plus 2 times the sine of theta, which is what I have in my original equation. Therefore, the graph is symmetric with respect to the line theta equals pi over 2. Finally, we can check for symmetry with respect to the pole. The way we do that is replace r by negative r. We get negative r equals 1 plus 2 times the sine of theta. This is not equivalent to the original expression, so the graph may or may not be symmetric with respect to the pole. Now, because I do have symmetry with respect to the line theta equals pi over 2, I'm going to choose angles theta between negative pi over 2 and pi over 2. And then we'll evaluate the expression. So we have that r equals 1 plus 2 times the sine of theta. Like I said, we're going to choose values of theta between negative pi over 2 and pi over 2. So we start with negative pi over 2 and then choose some other friendly angles like negative pi over 3, negative pi over 6, 0, and then pi over 6, pi over 3, and then pi over 2. So now let's find the values of r. For example, when theta is negative pi over 2, we're going to have 1 plus 2 times the sine of negative pi over 2. The sine of negative pi over 2 is negative 1, so I have 1 plus 2 times negative 1, which is negative 1. Similarly, I have when theta is negative pi over 3, I get 1 plus 2 times the sine of negative pi over 3. That's going to give me 1 minus the square root of 3 because of the fact that sine in negative pi over 3 is equal to negative root 3 over 2. So I have 2 times negative root 3 over 2, which is where the negative square root of 3 comes from. This is approximately equal to 0.73. Continuing in that fashion, I obtain the remaining values of r. I'll leave it to you to verify that these are in fact correct. So we're going to plot the points r comma theta on the polar grid and then use the symmetry with respect to the line theta equals pi over 2 to find the additional points, and we obtain this graph. Now, here are some of the points that we have. For example, we have the point negative 1 comma negative pi over 2. Draw the angle negative pi over 2 and then go 1 unit in the direction opposite. Another point is 1 comma 0. So the angle is 0, and then go 1 unit along the polar axis to here. Or 2 comma pi over 6. So here's pi over 6, and then go 2 units to the point right here. Or 3 comma pi over 2, and then 3 units up. So that gives me this portion of the graph, and then use the symmetry with respect to the line, theta equals pi over 2, to obtain a complete graph. What we have here is a limacon with inner loop.